So welcome everyone to our Meet the Engineer in May, and it's kind of something we thought up during our April as ASC month. And Jeff from Red Hat and Phil were more than kind of to agree to participate. And then next week we've got a VMware engineer coming in to discuss things. So Phil's going to do a two-parter. One is I want to talk about containers and Kubernetes because a lot of us don't know much about those. But we also wanted to make this kind of a talk where Phil can talk about his life as an engineer at Red Hat. So we're kind of doing a dual purpose. Phil was able to switch gears for me and do both. So without further ado, I'm going to turn it over to Phil Moses and let him give an overview on what he does in the Red Hat organization and what his role is. And I just want to say thank you again, Phil, for being here, and really appreciate it.
Sure, thanks. And in the spirit of time, I'll keep moving along here, right? Want to talk more about things and less about myself. But again, day in the life, very good example here, right? We have to pivot and change at the last minute quite often. That's what we did today. So what we'll do is we'll go through a little bit about, very briefly about myself, a little bit about Red Hat, about open source, and then we'll get into the container things, right? So my name is Phil Moses. I am a architect with North American Commercial, basically with the OpenShift team. As an architect, I can have my hands in any projects. I pretty much focus on OpenShift, which is our enterprise Kubernetes, and we'll get to what that is in a little bit. Basically, it's our flagship product for Kubernetes across the board. Lots of work right now, lots of fun, lots of new tools, right? So without further ado, let's jump into this, right? Just a little bit of a background. As a kid, as an adult, joined the Marine Corps, did 6 years in the Marine Corps, came out of there. Actually, I'm probably a truck driver by trade. Drove a truck, went to school, right? 1999, probably started working in tech, right? Joined on with Akamai, which is still around today, right? A lot of content distribution back then. Spent probably just about 2 weeks shy of 15 years at UC San Diego and Scripps Institution of Oceanography. Did a whole lot of work with ocean research, remote sensing, buoys in the ocean. Pretty much we managed a lot of the data coming out of there. What's really interesting about this time was working in research. We didn't have huge software and hardware budgets, right? So we had money from hardware, lots of federal projects, right? But line items, we could buy servers, we can build clusters, but we didn't really have necessarily money for software, right? Where this really benefited me was I was pretty much a Solaris administrator back in the day. Before that, Red Hat came out with Red Hat Linux. Well, it was out before then, but what we were doing is we were making a move from, a very large software license to, a subscription, right? Or in those days, enterprise Linux wasn't out, but we were going for a little cheaper path on off-the-shelf hardware and building our own clusters. So for the 15 years, right, I didn't have a lot of support. I didn't have, a lot of a deep pocket that we could go to, right? It's opening up open source. What tools do we have? How do we build this? 2016, I left and took a role with Facebook because I really wanted to get into larger clusters. Worked for them for about 2 years. I'm in San Diego. I moved to Oregon for that role. I wasn't real happy with the location and I missed home a lot. I missed the beach. So came back to San Diego. Did a little bit of work with ServiceNow with a small communications startup. And in 2018 to 19, right, Red Hat contacted me and it was an interesting deal. We'll get into this real quickly, but basically, they contacted me and said, okay, you have a lot of automation experience and you've done some really large builds with clusters and different things with Facebook and the background of that. But, they said, we would like to bring you on as a, automation consultant. Okay. I moved forward with there and then I showed up and they sort of said, where is your interest, right? And this is when we get into really the open source, the spirit of it, right? The managers were, what do you want to work on? And at the time I was like, I want to work on containerization and automation. So we pushed towards OpenShift, right? And this is sort of where the industry is going. And this is, like I said, the spirit of open source a lot, right? Is really where can you excel and where can you add value to things, right? So very good opportunity for me there. I was going to talk a little bit about, what do we do at Red Hat? Like, these are some of the industries, some of the things that I worked on, right? Lots of financial services, insurance and manufacturing, right now, working with energy and manufacturing, splitting 2 projects, but a lot of Fortune 500 companies, very large scale companies, some small ones as well, but we really focus on more in services and professional services, more mid to large customers. As far as software subscriptions, these go, right? We're across the board. We can use it anywhere. So moving forward, right? How did I get here? It was really a path of, I bounced around, did a bunch of different things. I enjoy Red Hat Technologies, probably worked with them for 23 years, probably 20 years when I came in. That's not saying you have to do that, right? Like, I wanted to go through a few of the things as you're going through Red Hat Academy, as you're learning different things, right? Like, what are some of the sample roles in Red Hat? Obviously, I'm not going to say top of the totem pole, but yeah, definitely the top of the top is, we have our software engineering. And people might debate that, but really your software engineers, right? They work on engineering of software. They work on the development of that software. They work on maintenance, right? These are your pure coders. They're thinking about things. They're thinking about how to write the software, what's going to work in a large environment, right? And these are the very intelligent and very established folks, I guess you could say, right? Pure software engineers. Outside of that, right, we have professional services, which is where I work, right? You have a wide swath, not swatch, but a wide swath of responsibilities surrounding products and services. I put this together in 38 minutes this morning when we made the change. But, we have consultants, we have architects, we have project managers, territory and service managers, right? Your consultants and your architects, you're doing pretty much the hands-on work. You're not a software engineer. You might be contributing a little bit to, you might be a software engineer by trade, but in the role, you're helping develop customers, you're helping to build out that software at the customer, implement products, right? You're leaning on your consultants. The architects are doing more design, meeting with C-level executives, right? We have project managers that are there that are basically running the projects with us involved. And then we have territory and service managers that cover a wider area or a region, I guess you would say, right? Behind that, technical sales teams. Account executives, solutions architects, account managers. When we start to look at this, the reason why I bring up some of these things is because, it's not a matter of, I have to learn to program, right? You might be an okay programmer. You might want to be a software engineer. You might say, I know operations very well. I know the software, I can learn software configuration very well, automation. There's a lot of different roles, lots of things going on. Behind that, right, we have technical support, which are literally the people who are responding to customers that are in the field, right? They are normally your specialization on a certain software or certain product within Red Hat, right? And there's their tech support for that, right? We have training development, right? Product courses, certification development, a whole department there. And then you have, even as far as, technical documentation, which are public facing product documentation, article support, et cetera. And behind that, you have corporate IT, which is literally your systems administrators, things like that. So the reason why I bring this up is because, Red Hat Academy, having access to the courses, learning the products, right? It really sets you up for a very large background with pretty much all of these things taking place. There's software engineers that are working in technical documentation that I know of, right? There's managers that have gone back to basically professional services and they're out there. It's basically, Linux is the platform of containers, which is where we'll go next, but Linux is really running, I don't want to say all, it's running a lot of computing in the world, a majority of it, I would say, right? Microsoft Azure, guess what's based off? Linux, right? These things are taking place. By learning Linux courses, it gives you a really solid foundation into any one of these and a number of different roles that, as you progress and where your career could go.
And Phil, I think too, one of the things to put in there is that depending on your personality, there's a role for you. If you are that person who doesn't want to interface with people, the software engineering may be the place where you go. I mean, you go and you code all day and that's what you're happy with. But if you like to interact with people and you like to do more, you may be on the sales side or you may be on the technical account side. So I think it's important for people to realize that there are so many different roles in IT, and as you show here in Red Hat, that support different types of personalities and different types of folks. So don't think that everyone who's in Linux is a geek that programs. I mean, they're not. They may be technical facing, they may not be. It just depends on their role.
Yeah, and I mean, the basis of that, exactly what you said there, right? It still comes back to collaboration. Even if if you're an introvert and you don't want to be out there with the masses, right? There's still some collaboration that needs to take part. And I just say that because we're going to get into that in a minute. But overall, it's a solid, if you're going to go into computing and Linux and containers and basically Kubernetes orchestration at this point of the world in 2022 where we're at, right? This is the foundation, right? From there, the world is yours. You go in the direction you'd want to go into, right? There's a lot of it there. So we talked about, different paths to how you get there, different roles, different types of customers. One of the things that I didn't note there, right, is like pure tech customers. We do have them and we have quite a few. The thing is that in professional services, you sort of fall into where you're working and who you're working with, and we do continuous engagement. So it sometimes, like for me, I've done a lot of power work and a lot of, or not power, gas and oil, and then some banking and some insurance work. So, that's sort of my customer base, right? We go through things, we do an engagement, I come off the engagement, I'm working somewhere else, and they have another engagement and they say, we want Phil back. So lots of flexibility, lots of different things to go into, right? That's the thing, very solid foundation. Right, when we think about this, this is sort of a joke, but what contributes to the success, right, in the roles listed? And in the old days, it was always RTFM, read the freaking manual, right? And we sort of have a deal, right? Read before you ask. We get into this, right? Contributing factors of success in these roles, right? Not all inclusive. Like I say, you don't have to be the best coder in the world to go to work for Red Hat or to go to work for Microsoft or Amazon or anybody else, right? But, first and foremost, there is a lot of documentation to read, and, you're encouraged to read the documentation, but, you're not alone, right? Review the docs first, then ask questions, right? Open source, we'll get to this in a minute. This is the spirit of it quite a bit, right? Collaboration, it's really a must for success in the majority of the roles. You can be an introvert, you can do strict software engineering, you can just want to code all day. You still have to be able to bounce your code off somebody else, integrate with things, have some limited set of soft skills, right? We're in a whole new world. We're changing rapidly. And really, we have a ton of shared services, right? So what we're getting into with containers and container orchestration is really a whole new set of collaboration and shared services and how these things are working together, right? Flexibility, like today, Semper Gumby, always flexible, right? You have to be able to change. If you sit down and you say, I want to do one thing and one thing forever, probably not the best approach at this time now. One of the biggest things, and I think that if you're here, right, you're learning a new thing, especially with Red Hat Academy and whatnot, initiative, right? Be willing to take ownership and responsibility of tasks, be curious. You're looking at things. I'm not sure how this works. Labs help a lot if you have a lab. If you don't have a lab, virtual machines and containers help a lot because you can try and you can break things, right? But that initiative to go out there and say, I want to learn something new, right? We are learning things. I've been doing this 23 years. I learn things every day. And part of that is product release cycles, and part of it is just technology changing. I probably can't keep up with guys getting out of Stanford, at a computer science program. I just can't, right? They're going to be a better programmer. They're going to know more about that, but I know more about this, keeping things moving. And that goes into problem solving abilities, right? Long gone are the days of one problem, one solution. We have entire ecosystems of, here's a problem. How do you fix this? Especially in shared services, shared technologies. You're getting into, platforms that you have authentication here, passwords and secrets here, a web server here and a database there, and really figuring out, being able to slow down and say, how do these all connect together and where are we at with that? And, last contributing factor, or not last, but something that my mentors tell me all the time is, don't try and boil the ocean, right? We try to keep things simple when possible. Things can be very complex, but you break those down into small sets and small pieces, and you move forward with those. Any questions that I would need to address right now, or?
Not right this second. I did have someone ask Phil if we can get a copy of the PowerPoints. If you'll send me one of those, I'll distribute them through a Dropbox to everyone, if you will. If you're willing to share.
Yeah, I'm gonna make a couple of edits to it so that I don't have swatches. I have
Instead of
swats and
swatching,
things
yeah,
like that.
okay, no problem.
Yeah, so we get into this, right? And people, now it's a little more common. 10 years ago, 20 years ago, probably it wasn't, right? People said, what is open source, right? We don't sell software licensing. Red Hat doesn't, right? We sell subscriptions. People say, how does that work? Like, how can you do this? How can you take this and you put all your code out there? It's free. Why would people pay for it? There's a lot of different reasons, right? We offer support. We have upstream versus downstream. If you're familiar with Linux, Fedora may be an upstream. This is where the development's taking place. This is where changes are being made and implemented and tested. And then your downstream, it basically goes through its cycles and it ends up as, Red Hat, right? Or Enterprise Linux. And that's our downstream product, right? But open source really is about more than developing software. It's how Red Hat built their company, right? It's why they've been so successful. And a lot of that really is collaboration. Oh, a little slow there, right? We think about things in open source. We think about 1 million+ projects now in open source, in 3 large parts are, participation, integration, and stabilization, right? It's people working together. Probably people would debate it one way or another. If you think of things in the security mind frame, probably what's going to lead to a more secure product in the end. 1 million eyes on something, dissecting it, tearing apart each piece of that, or a department building a security tool and saying there's 10 people or 100 people that know this, right? We're open. We open it up to the world. You can contribute. You can contribute with as little as writing documentation. You can go to GitHub and you can pull documentation of OpenShift, and you can find a mistake and you can submit a PR and publish it back, right? It's going to get approved. It's going to go through that, but really it's participation and integrating that. What we end up with a stabilized product in the end. What's our culture? Talked about this a little bit already, right? Loads of collaboration. We believe, right, we can share problems. We can solve problems a lot faster. I've worked in an environment before where it was very, I guess you would say, performance reviews were very much based on what you did, and people were very negligent to share what they were doing, right? They wanted to do them all themselves. They didn't want to share their ideas. They didn't want to go about that. Open source is a little bit different, right? We can achieve more with 100 than we can with 2 based on the situation. Things might vary, but that's, what it is. We get into really this transparency behind that and the security that I already talked about. Really, and then when we work together, right, we create the standardization of what we have there. What are some of the enterprise solutions, right? Or what's some of the reasons? Rapid iteration, the innovation is off the charts, I think. Community development, the collaboration solve common challenges. We have user interfaces, acceptances of changes upstream, like I said, Fedora being an upstream, RHEL being a downstream, right? QA and integration. And then really we get into a predictable, stable lifecycle support, right? That we're really trying to build on the back end. And, when a lot of people say, people say to me, oh, you work with Red Hat, you make Linux, right? There's a ton more to it here, right? These are a lot of the products. Actually, virtualization is going way in favor of container native virtualization on Red Hat, but we have Linux as the base. This was the starter here, OpenStack, right? We have storage, satellite. We get into Ansible automation platform, which if you're not familiar with it, I'm sure at some point you're going to be, because this is pretty much becoming a standard across the board. CloudForms, which has gone away, but CoreOS, this is what runs our flagship product, which is OpenShift, right? What is CoreOS? CoreOS is basically an immutable version of Red Hat Enterprise Linux, right? What do we mean by immutable? You can change it if you really want to, but basically how it works is a large appliance, right? We're not going in and patching this. What's taking place is we're taking nodes down and applying an entire new operating system and image to that machine. And that's going to be CoreOS. It's very much set up for the containerization in OpenShift Kubernetes world, right? OKD, which is our basically pure OpenShift, pure open source OpenShift community. That was hard to say. And then we get into Fuse middleware, which is JBoss, Java, a lot of things around there. So Red Hat, are we just Linux? Absolutely not. Tons of things going on, tons of projects that are out in the open that are sponsored by Red Hat, or Red Hat has people taking part in. Lots of things going on. Right? Any questions there so far before we move into virtual machines and containers?
Someone asked, isn't CentOS dead?
It's not dead. So here's what took place, and here's the long and short of Cent. So Cent was basically, Cent basically was taking Red Hat, right, and taking the, again, open source, everything's out there in the open, repackaging it, making it Cent, right? And that went on for a long time. And I don't know all the marketing details and every strict wording behind it, but basically what happened was Cent went from the downstream RHEL to an upstream project. So previously what you got with Cent was literally a repackaging of RHEL, which is downstream. So we go through Fedora, we go through different upstream channels, you vet out your bugs, you test different things, you create this product, which is RHEL. We release RHEL, and immediately behind that, Cent is remade basically as another distribution, right? Based on Red Hat Linux. Where it's gone in the last year, I believe, whenever that took place, I don't really remember, time sort of just flows into each other now with COVID. It's become Cent Stream. So Cent is still there, but it's the upstream project rather than downstream, right? And this comes into play a lot, not so much at home, and if you're using a Linux distribution, maybe if you're playing with tools and different things, that's fine. In industry, it comes out a lot, quite a bit of supportable products, right? Product life cycles, things like that. I will say that at least 3 of the companies that I work for that included Facebook, I'm not sure where they're at now. At that time, we had a little over 1 million servers in the data centers. And, you know, I was there for the Cent 6 to Cent 7 upgrades. I believe from what I heard from somebody there was that they actually had Meta now had a pretty big part in this as well, as far as turning it into an upstream project or wanting it to be an upstream project, because there are bugs that are fixed faster with upstream than if you're waiting for that downstream project and everything to get released and pull it out. So Cent is not dead. It is still there, but is now Cent Stream, which is the upstream.
Makes sense now.
Makes sense. Thank you.
Yeah. Other questions, concerns? Yeah, so somebody called it out here, right? Open organization, the old CEO, Jim Whitehurst, right? Phenomenal book, talks in depth about the culture of Red Hat, right? About open source in general, right? Jim Whitehurst, who was the CEO, you know, he came from Delta, which is a very much top-down, how would you say it nicely there? Probably authoritative organization, right? And if you read the book, you know, Jim talks about in the beginning, sort of coming in like with anybody else and saying, what is this open source deal? How do you make money off of this? And how did this work where you're basically a flat organization, right? Meritocracy. I can pretty much go to my leaders in open source at Red Hat. It doesn't have to be about software. It can be about process. It can be about whatever it needs to be about, how we're engaging with customers, how we're delivering products. And I can walk in and say, this is what I'm seeing, and here's data behind that. And I think that we need to change X and Y. And in a true open source organization, you know, that's considered, right? And, you know, you collaborate over this and you get parties involved, and what comes out is the best idea wins, right? Or the most appropriate for the situation. We shouldn't say the best, right? Because in the end, there's a couple of things. We're still a business, right? You have to create revenue. And then you have customers and they have to have something to go off of, right? We can't just give them, you know, whatever. We have to have a baseline. You know, the deal is close to that baseline, open organization, the entire whole 9 yards. If you're interested in the business end, it's a phenomenal book, and Jim would probably be more happy if you bought it. Other questions before we got, so yeah, 30 minutes left, right? And we're going to talk a little bit more about virtual machines and containers, and then get into containers and Kubernetes and OpenShift. All right.
Let's go forward. Thanks.
Okay, take a quick drink. So what are these containers, right? And how does this work out? Where are we at in the world today? A lot of people, or some people, may be familiar with, say, Docker, right? Here's Docker. We're going to build a Docker image. That's going to be a container. You're running a single container in a machine. Okay, we do that. We do that a lot for testing, right? We move beyond that. We get into Kubernetes. We get into OpenShift, Tanzu. There's a few different products on the market. Apache Mesos, which is very similar. But these are the container orchestration platforms, right? And we'll talk more about this in a minute. But basically, you're literally taking one portion in a container, and then you're saying, okay, what if we have to scale this out, right? Then we get into orchestration. How do we do that? But let's talk about historical, what we used to do, right? We used to have large, what we refer to as macro, right? Large applications. You have a data center, you have a server, maybe you're running a server, and on that server you're running HTTPD, and you're running a database, and you're running something for authentication, right? And maybe you have it on 3 different servers talking to each other. You have just a server that's sitting there, and maybe it's idle half of the time. Maybe it's spiking up with usage. Sometimes it is, sometimes it isn't, right? So you start to think about these things, and you go, oh, I'm running a database server, and it does need lots of memory, but it doesn't need 100 gigs of memory all the time. Like, how do we do this? How do we start to think about the scale, right? So going to the back end a little bit there, prior to getting there, right? That's sort of the macro. People think about, okay, microservices are containers. Macro services are this old data center and this old way of thinking about things. And then we get into, people say, okay, well, what's the difference between a virtual machine and a container, right? A lot of people are very familiar with VMware and related technologies, where you can have a very high-end laptop or a workstation, and you can install multiple running operating systems there, right? And you say, well, we have a virtual machine, right? How does that differ from a container? And if we take a look at the slide here, right, on the left, we have virtual machines. On the right, we have containers. And you think about, a virtual machine will isolate the hardware, right? The container isolates the process. So we start to get into things. If we look at, a virtual machine as hardware with a hypervisor, we also see the hardware and the hypervisor on the right, and the container as well, right? And then in the virtual machine, right, you're seeing applications, OS dependencies, a kernel, and an actual VM or an operating system. If you think about this could be CentOS or Red Hat Enterprise Linux installed in a virtual machine, right? You still have a container, you have dependencies, you have these apps that you're running, and maybe you have shared libraries. All of these things are trying to work together, right? What we have on the container side of the house is, broken out here in green, is we basically have the hardware, we have the hypervisor, which would be OpenShift in our case, right? The container host, which is the kernel itself, and then you have the containers that it's a prepackaged unit, right? So you have an application, you have all of your OS dependencies, you have everything there. When we think about where we're moving towards now is CNCF, which is the Cloud Native Computing Foundation, right? We're talking about build it once, run it anywhere. So the old days of, I like Debian, I like Cent, I like Fedora, you can like whatever you like, right? We build an application and you can run that on any containerized platform. And that's really where we're going here. It takes a lot of the overhead off of both development and operations, right? And this is really where a lot of the focus of that quote unquote DevOps, which is quite the word now, is coming into play. DevOps being, this is a unique time because we have developers, we have operations. Historically, it was, developers going to build something and they're going to throw it over the fence to operations, and operations going to deploy it and see how it works and make sure it works and run it basically. Now we're into this DevOps world where maybe developers are working, to build containers, and maybe they're building the, a Spring Boot backend, and the operations folks are actually writing the manifest to deploy these, in an orchestration, right? So similar but different, right? And again, virtual machines are a little more macro than containers. We think containers, we think about running them, with millicores. You can actually take the CPU in an orchestration platform. You can take the CPU in each core. You can break out into millicores where you're giving a container 10, 100 millicores. It's actually slicing out that CPU just like you would do with memory. Just to reiterate here a little bit about it, right? VM isolation, you basically, right, these are the things on our left, right? We're talking about the resource usage, static and compute. I understand that in VMware in different places, you can actually, go in and change things, and there is some auto scaling that's taking place now. But on the right with our containers, what we're looking at is container isolation, a shared kernel, and basically, burstable compute and memory. You deploy a much smaller resource usage, and it basically scales up and down on its own within limits. If you don't give it limits, well, you could run into some issues, but it's scaling within the limits that it knows of. So similar, but different, right? Now we're going to talk about things overall with containers, pods, deployments, which is how we're deploying containers, services, routes, because this is where things start to get people, well, repeat that again. It gets a little confusing for some, right? So what is a container, right? So if we talk about containers, you can think about a Docker container, right? I build a Docker file. I'm going to create a container, and I'm going to run that on my Windows or my Mac or my Linux machine. And we're going to run this as an instance, and we connect to, whatever port mapping that we have taking place, right? But basically the container, as we talked about earlier, all inclusive, it's got everything built into it, shared libraries, operating system, everything that it needs to be is there. It's basically the smallest compute unit that there is, right? And the end goal is container orchestration. Well, not always, but in enterprise, pretty much, right? So a container is the smallest compute unit, right? Where do we get these containers? Containers are really created from images, right? So if we do a build on a Docker file, we would build an image, right? That image is probably going to be in a registry, and we're going to do a pool. We're going to say from sent, we're going to pull basically sent 7 or sent 8, or from rel, pull rel 8, right? So the image is at rest, and the container is basically the runtime environment of what's taking place, right? How do we build an image? Build methods vary. Often you'll see Docker files, right? People are building with a Docker file. This is external. They could be providing an image to a customer. There's different third parties, they're distributing an image just like you would have an old ISO, but rather than an ISO, you have an image, right? They can push it to a registry, right? Docker, Quay.io, different registries exist. How do these exist? Registries versus repos. Repo, GitHub, more code-based, right? Registry, where our images are going to be pulled, right, to run our deployments from. Within OpenShift, source to image is a build strategy that is utilized that basically we're taking source code and we're giving it a Git directory or a Git project where everything is contained. And it's basically pulling it onto the platform, doing the build, and then launching everything there, how we tell it to. And another, concept there on OpenShift is basically a build config, right? So the end goal is that you have not really, you're crafting some code, but it's not really code, right? You're crafting a Docker file, you're crafting a build config, but basically you're saying, pull these out, pull this base image, right? You start with a very small base image. We have different ones. We have universal base image, and you have UBI minimal, and these are really pre-packaged bases. And then within your Docker file, you're going to give it a level of configuration as much or as little as you need, to basically create the end image of your, if you're going to run an HTTP server, you're saying pull rel 8, right? Install HTTPD and utilize this configuration, right? You can think about that in its most basic form. If you want a web server, you're just doing a Docker file, you're pulling your base image, you're using your base configurations, and you're publishing an image that will run as a container as an HTTPD web server, right? Basis. Mentioned this before, right? We store these images in basically an image registry. Quay.io is one, JFrog is one. There's an internal one, Azure DevOps, right? If you're using one of the cloud providers, basically there's plenty of them. Each one has their own. You can use external ones, but basically we pull these, we run them, containers running on the platform itself, right? We get into the concept of pods. So how does it, so now like people start to go time out, pump the brakes. You have a VM, you have an old server, or you have a VM, and then you have a container, and now you have a pod. How does, like, where do we start to break out here, right? So containers can be wrapped into pods, right? Which are units of deployment and management. And when we think about this, we think about, okay, well, what would be an example of that? Or why would we have a pod? Why would we have a pod? Why not just run them independently? So if we package containers, or if we take pods, if we take containers and we run them as a pod, multiple containers in that pod, we do things like we share network, right? And we share storage. And you say, okay, what is an example of maybe where a container runs? In the entire ecosystem, you know, one of the things that's very common are, say, a sidecar container with a proxy, right? So maybe we have and actually here's a perfect example. In an HTTPD that we talked about, that minimal container, maybe we're launching a web server in an HTTPD container, right? And we deploy this and we say, okay, well, we're having problems with it. Okay, so we need to run some analysis on network traffic, but we don't have netstat installed. We don't have anything to do TCP dumps or anything like that. How do we do this, right? Then we get into the thing, an idea of, say, an example would be sidecar containers, right? So we have our HTTPD. You know, if a developer developed that HTTPD, or better, maybe a Spring Boot application or something, and on the operations side, we need to do some network analysis. We don't want to go to the developers and say, include a bunch of this network stuff that you're never going to use, right? We just need to troubleshoot this, right? What can we do? We can launch a container next to it, sidecar container, that's going to share the network, right? And we can start to pull that data off of there. Tons of other uses, you know, you'll get into things where you can see init containers, right? And these are things that basically come up and they run a configuration basically within a pod, or they're configuring something that they're going to run first before the HTTPD container runs, right? And let's see, I should have jumped there. Yeah, let me go two more, right? So basically, we get into it. We have containers. Containers have specific deals, right? A group of container is basically a pod, right? And we're thinking about all of this. I know I mentioned it at the core OS, the operating system level. I know I mentioned it before with images, right? Our end image, you know, we're making these to be immutable, right? But if these are meant to be immutable, right, how do we configure it with dynamic data? And we think about this and you go, okay, so I'm writing a web page and my web page is going to update, but you're saying that my image is going to have this static configuration that's put in at the Docker time. So how do we get around that? What do we do, right? So we have a process which is called config maps, right? And you can think as config maps, if you're familiar, if you're doing the Red Hat Academy, you probably do some sort of web server that you build there or something along the way, right? But config maps allow you to decouple configuration artifacts from the image content. So this is where we get into the build once and run anywhere, right? We have Apache, or we have a base HTTPD web server that runs, and you say, okay, well, I want to run that with my content, not the content that's provided with it. So we set up a config map, right? That's basically being mounted as a volume in the pod. And what this is we're saying, take this storage, right? We're going to take this configuration, put this in storage and mount that on the pod so that when it comes up, you can overwrite, you're not overwriting, but if you were using var www root, right, within the container, you can mount that config map as a volume at var www root that has your information in it. How does that work out in the end, right? So like, where's the benefit to that? The benefit is you start to get into things like GitOps and you're storing everything in Git. Your changes move away. You're decoupled from making changes basically at a server level, like we were doing back in the macro days, to now you're just making changes in Git. And you're basically deploying those changes with the image, or we can get into some really advanced GitOps topics, but we won't. But you're basically making your changes in Git or making your changes external to that image. So that image, even if your configuration is broken, the image isn't broken. It still works, right? Blow out your configuration, do it over again. You're not rebuilding the entire image. You're just launching a new config map for that. And when we talk about that, let me go back 2 steps here, right? How does this all work in the grand scheme of things? How is this working as, you know, in a platform as a service or at a Kubernetes or an OpenShift level, right? We have a concept of replication controllers, right, which ensure a specific number of pods are running at any given time. And behind that, we have deployments and deployment configurations, which define basically how to roll out new pods. So if we rewind 15 minutes and we think about when we talked about burstable and scalable things, right, we can deploy, if you think about things at maybe say a football level with the Super Bowl, right? The NFL probably now in the middle of May, maybe during the draft, but in June 3rd, you're probably not getting a ton of traffic to NFL.com, right? But as the season starts, right, as the season's kicking off, then those web servers are going to get under much heavier load, right? So we work through deployments and deployment configurations to spec things out, right? We're saying give this amount of CPU, give this amount of memory, and basically as traffic increases, we're scaling up these, right? Replication controller would say, you know, maybe you have a minimum of 2 and a maximum of 100, right? But at each level, once you pass a threshold, you're going to deploy another pod and it's going to bring that up, routing your traffic, right? And as you go down, you're going to go down. So on Super Bowl Sunday, when you need 100, you have 100 of those pods. And on June 5th, when really nobody's paying much attention to football, maybe you have 10 of them running, right? So we work through these things, right? So if we think about it, the overall, we have a container, which we develop an image. We launch the image as that container running, right? From there, we get into pods, which is a group of containers. Behind that, we have replication controllers, which are run by deployments and deployment configurations of how this is scaling and how they're going up and down. And I'm sorry if I'm talking way too fast, but got to get all this in here in an hour. And another deal with config maps, right? Very simple demonstration. This would be, you know, say database configurations, right? You can have one single image that you're going to run both your development database config and your production database config off of. That's the image. Obviously, you're not going to log into or use the same authentication scheme with dev and prod, right? So you can just simply supply a config map. Hey, I'm dev and my password is 123. And, you know, if that gets offset by accident and tried to get deployed to production, right? Wrong config map, wrong authentication, you're not going to get through to there. We talk about things a little bit different too with containers and pods, right? We don't really talk about passwords so much. It's more of a terminology that we refer to as secrets, right? Secrets provide a mechanism to hold sensitive information such as passwords, certificates, different deals. When we talked about the shared services and collaboration earlier, there are things like secrets that are present in Kubernetes and within containers that we're getting into this whole realm of storing those in an actually external service or possibly a different service provider. Good example was HashiCorp Vault, right? We're running multiple OpenShift installations across many customers where pretty much all of their sensitive information is stored within an external secrets provider, right? So what's the shared service? How does this come into play? Well, you have to get your pods and your containers to actually extract a secret from another provider, right? So it's literally, you can run when we talked about a sidecar container, maybe it's going to spin up and it's going to say, you know, what's the password for Phil? It's going to reach out to the HashiCorp Vault and say, I need the password for Phil. It's going to bring it back to that sidecar container and basically make that mounted as a volume for the pod itself, right? So what I'm trying to get at here, and I know it's complex, but lots of shared services, lots of different terminology, but in the end, they really come back down to the same thing, right? A secret's a password. You have to have it available somehow. Talk a little bit about networking here because we have
Phil,
10
real quick
minutes.
question. Ryan asked, talking about a container
It's fine. I got it. And he's only got 10 minutes.
Okay, well, I still
Yeah.
want to ask it because I think it's a
All
good question. That is, you know, a container is kind of like compiling a program with all the dependencies in that container for that one app to run.
Yes.
And then you can take that container and build it out, and then from the repository, pull that container and use it over and over again. But you're now even talking about with automation, being able to take these other configurations and building one container and then using it for 5 or 10 different purposes just by using the automation on the back end.
Yeah, pretty much. I think my last project in fall, when I wrote off of that one, that's exactly what we were doing, right? And honestly, we were not logging into machines, platforms, period. Everything was going through Git. So literally on the clusters, we were at read-only privileges, right? And basically that automation, you know, that's a huge talk to get into, but that automation was basically running to say, pull everything through Git, right? Everything that's checked into Git is going to go through a peer review or a pull request, right? Where somebody's going to approve it or deny it, right? And every single thing. So this is huge in the world of auditing right now, right? So every single thing is going through Git. So there's a record of each change that's made, and that's not pushed out until there's a peer review, right? So your automation becomes this culture that we talked about earlier, right? Rather than somebody logging into a cluster and making a change, right? They're actually making a change and they're pushing it to Git, and a team is saying, you know, you need a quorum, right? You need at least 3 approvals to approve that, right? And then we get into, you know, what used to be postmortems and a lot of finger pointing and blame, right? We get away from that. We get to basically peer review. And, you know, if something goes wrong and that automation took place, you say, you know, Phil, Joe, and Mary, you guys approved this. What happened here? Like, where did this fall through the cracks, right? And honestly, I work too much and probably don't sleep enough. And in the end, you make mistakes, right? A lot of this contributes to that, but 100%, you get into different deployment strategies, and there's a lot of it going on right now. And, you know, one part of things, some people say that's automation, it's taking our jobs. You know, that's not the case. There's more work than we can do right now. In this automation, what it's doing is we're really eliminating the human mistake process, right? Computers will make mistakes if you tell them to make a mistake. But once you get it down there, the only way it's going to stray from that is if there's AI and it knows itself, or if somebody changes it. So 100%, that's where we're going. The end goal, I'll get to there in a second, but, you know, container orchestration with automation behind it, and it gets to be hands off. Very quickly, with 7 minutes to go, right? One of the things that's challenging for some to pick up, right, is how software-defined networking works. Obviously, we expose very few ports to an OpenShift cluster on the outside. Things are basically routing through those ports and coming into a cluster. And, you know, how does this all work, right? We basically work on an idea of services, right? So services, they provide the internal load balancing and service discovery across pods. So if you're bringing network traffic into a cluster, that cluster, just like DNS, anything that happens outside of that, it's taking place within the cluster itself, right? So if you think about a front end, if you think about a back end, a database, these different things, these can have services that are talking to each other in the kernel, or I'm sorry, in the cluster itself, right? None of that exposed outside of the cluster. So the services are internal within the cluster, right? And behind that, we basically have, this is how the applications talk to each other, be it the database, HTTP, different thing, analysis, whatever you have. And behind that, we have routes, right? Routes are what's actually exposing that to the outside world. And basically what we'll have is at the top level, you have a load balancer, your traffic's coming in, you're saying go to website.phil.com, and it's coming in and saying, I know it's here. It hits the load balancer that routes it to the cluster itself. And then depending on what is in that request, it can route it to different places. There's definitely, you know, one of those things, if you think about it, you know, there's a book app example that's there for service mesh, which is an advanced networking with software-defined networking. But basically there's one image. And when we talk about those configuration maps, there's different things that it can route to, right? Maybe it's routing to a review of a book, right? Maybe it's routing to a overview of a book, and maybe it's routing to a sample chapter from a book, right? But literally running each one of those in a container, right? So even that with resiliency in mind, if your reviews portion goes down and for some reason that's offline, then your book info app can still stay up and people can still see, you know, what's a sample chapter, or, you know, what did this, you know, where can I get this thing? But anyways, so internally services take care of our software-defined networking. Externally, they're exported through routes. And very quickly, we have what's called persistent volumes and claims for storage, right? A persistent volume is an actual storage backend. Think of it as a big container, not container, bad word, a big storage application that allows you to make this available to the cluster. And then the actual containers themselves or pods will make a persistent volume claim or a claim to that. So you have two sides. Your operation sets up the storage itself. Developers don't need to worry about storage or how to get into that. They just say, I want to claim, I need 10 gigs, and you take care of that 10 gigs. And in the end, this is where we've all been waiting for, right? This is what we get into here, which is our end OpenShift deal, which is the whole orchestration engine. Very much 100% running things like this right now. We have our infrastructure. This is running the APIs, and at the Kubernetes and OpenShift level, all of these things are running, monitoring, networking, everything there. We're into a world now where we're definitely deploying full virtual machines to OpenShift, right? But we have a mix of virtual machines, containers, and serverless all running on the platform. There's a lot to be said in a few minutes. Does anybody have questions before we wrap it up? We have like 5 minutes to go.
Anybody, if you do have a question, you can take yourself off mute and ask.
Yeah.
The
Also,
networking
Phil,
thing.
one thing. Oh, go ahead, Ryan. Go ahead.
Shoot, never mind. I forgot what I was going to say.
That's okay. I tell you one thing I would love to see, Phil, is maybe get a chance to come meet with you again and have you actually run through some examples of actually creating some of these, like spin up a VM and using Kubernetes, spin up a container and show the process. So kind of take this what we've gone here with kind of the basics and show us some examples of how you're spinning these things up and showing them. I think that would be really neat to see.
Yeah, I would love to do that. Today wasn't enough time.
No,
Right?
I agree.
These are longer processes, but if you go to Red Hat Developer on GitHub, right, there's tons of it there, starting from Docker and working its way through. There is a tool called Code Ready Containers, CRC, right? And it is a bit of a resource bear, I guess you could say. I think it takes about minimum 16 gigs, maybe 12 gigs of memory at this time. I'm not sure what it is, but for anybody, I'll add this to the slides as well. I should have before, didn't think about it, but Code Ready Containers, it's a standalone all-in-one OpenShift. Literally, you can deploy it, and it's not made for production, but it's made for testing. And there's that. And then the other thing that I would say would be, for anyone who's interested, you can go to learn.openshift.com, and there's, I don't know how many now, there used to be about 24 different labs that basically it spins up a sandbox, and you can run that, boom, you're running in a web browser, it's running, and you can see a deployment taking place and walk through those. So learn.openshift.com, there's a ton of resources available. I'll see what we can do and get an actual demo on the calendar at some point.
Okay. I also posted learn.openshift.com to chat, and also posted again, NetDev Group or NDG has a free cloud and virtualization concepts course, which has an entire chapter on containers and Kubernetes. So that's very, very neat. And if you've ever done any of the Linux courses on the Cisco Networking Academy, when you go to do the labs, it actually spins up a Linux box. Well, that's a little container that's actually running on, some of them are running on servers here on our campus at Stanley Community College. So it's, we've seen, and we can run a large number of those containers on servers that honestly would be kind of useless in a large VM type environment, but with running containers on them, we can spin up just hundreds and hundreds of VMs because of how small those containers can be. So any other questions? Phil, we'll let you go and wrap up.
Yeah, I just want to say thanks for taking advantage of it, right? Obviously, Red Hat Academy and that, phenomenal program, especially the rate of cost. I don't know how much you guys are paying, but I know it's not like taking a course, for $3,000 that some folks are spending for, 4-day courses. So thanks a ton. Thanks for having me. Thanks for considering Red Hat. And yeah, hopefully I didn't talk too fast, but there's a lot to cover here.
There definitely is. And we thank you very, very much for being willing to meet with us. And I'm gonna go ahead and stop the recording. So hold on one second.